just like to welcome our panel of experts. We have Ken Eddleston, our Senior Lighting Specialist from Chalmit.
Hi, everyone.
We've got Sean Rogers, our Lighting Product Manager from Killark.
How's it going?
And finally, we have a new face, Karl Slingo, our Lighting Design Engineer from Chalmit. So welcome, everyone. So now we're just going to launch into the questions. So first question that was received, what is emergency lighting and why do we need it? So Ken, if you want to kick off with that.
Sure, thanks, Liv. Well, a lot of emergency lighting really comes down to specific standards, site standards or regional standards that apply to wherever your project is. So for us, we typically focus on, for us within Europe, we typically focus on a couple of lighting standards. That's EN 1838 or BS EN 5266. Now, within those standards themselves, there's a couple of differentiators, let's say, between the different types of emergency lighting that are required. Now, the first type is emergency escape lighting, which is essentially for immediate evacuation from a premises or a facility. The second type is emergency safety lighting, which tends to be for safe movements when immediate evacuation is not required, so people can still move around the facility in the interim. The third one is standby lighting, essentially where there is emergency luminaires powered by an alternative power supply so that normal activities can continue. Now, for the Chalmit and the Killark brands, the industries that we typically operate in safety tends to be the #1 consideration for above anything else almost. For the harsh and hazardous environments, we really need to ensure that safety is critical and that there is sufficient safe illumination provided so that people can escape from the facility, from the premises, and avoid any risk of ignition or potential ignition for the explosive gases and dusts that are commonly located in the environment or can be in the environment. So we tend to focus more on what I would call escape lighting, i.e. to provide safe escape, safe egress from a premises. You tend to have dedicated emergency lighting to do this, along a defined escape route or an overall area, whatever is defined by the individuals or the site. And you tend to supplement that with what I would call wayfinding illumination. So what I mean by that is above door exit signs, that kind of application. Essentially what we're trying to do, what we're really focusing on is allowing people to see clearly, avoid hazards, avoid obstacles, and move swiftly to the nearest escape, nearest exit or muster point, whatever that might entail. So we need to highlight changes of direction, changes of elevation. We need to focus people in a specific direction so they get to that location as quickly and as efficiently as possible. One kind of example or one kind of analogy I like to bring it back to is going to the bathroom at night. Now bear with me, folks. I'm not going to go into details about my evening habits, but sometimes when you get up and you go to the bathroom, use the toilet, whatever that might be, you'll go in. You can see quite clearly because your eyes are fully adjusted to the darkness. But when you go into the bathroom, you switch on the light. It takes a couple of seconds, but your eyes will adjust pretty quickly. Now, when you leave that bathroom, you turn the light off. It takes a lot longer for your eyes to adjust to the darkness. Okay, so you need minutes rather than seconds to really understand and see around you. So that's why you tend to find that a lot of households do have what I would call night lights, like little plug-in lights in the sockets, just so to like illuminate your way back to the bedroom. The exit signs that we typically recommend, that we typically utilize on sites and projects, is your night light, essentially your wayfinding illumination to guide you back to your bed or to the muster point.
Great, thank you. Great analogy. Although, yeah, glad you didn't talk about your bathroom. That was good.
That's another session.
Yeah, for sure. So moving on from what is emergency lighting, can we talk a little bit more about what options there are for providing emergency/escape lighting? Sean, if you want to kick off with that one.
Yeah, I can take that. So, from stateside, it's kind of similar. We have very, it's not quite harmonized, but there's a lot of parallels between them. We have kind of two major codes that we deal with, which is IBC, International Building Code, and then NFPA, whether that's 101 Life Safety or any of the other NFPAs that they have out there. I think there's like 6 or 7. But you have to understand the authority having jurisdiction and what codes they're going to be implementing and what they're going to allow as permissible. And that kind of gets into the granular details of, lighting levels and everything else. So my one recommendation is always check with the site, the manager or whoever's managing the project, because you don't want to have an embarrassing fix that you have to go through and redo because you did it to one standard or one code versus the other. So that's my little PSA on that one, just to make sure that everybody takes that into consideration. But back to the question, there's really kind of three main types of battery backed up systems that we come across. So you have power generation. So that's either in the form of a turbine, diesel generator, gas generator. I've seen some novel, or heard of, haven't seen them in actual practice, but flywheel kinetic energy generators. It's just basically something that as soon as the power goes off, this is going to be able to kick in and illuminate the circuit. The second type is a UPS, uninterruptible power supply, and this is batteries, and it offers kind of the same ability. Typically, though, these will come on, and instead of being AC, these will be DC, that they power the same circuitry. So you'll have your lights that are all the normal operation, and then whenever an emergency happens, it'll power that line with DC, and same goes for the generator, but those are typically AC. And then the other one is what Killark and Chalmit tend to offer, and that's the integral battery, or battery that's actually baked into the electronics of the fixture. Okay, so essentially it's also called distributed battery network systems. I think it's a term I've seen before. And basically it's the luminaire has the battery inside of it. So that has, like, for muster points and things where they're far away from the generator PS, this will be a battery system that you can put out there and illuminate an area.
Perfect, thank you. Ken or Karl, do you have anything that you would like to add there?
I think with the UPS system, that it's not only a DC system, they can also be have inverters associated with those UPS systems, so it maintains an AC supply. Other than that, no, that was a great answer, Sean.
Yeah, thank you, Sean.
I think, certainly there's different types of emergency lighting. Certainly some of the projects that we've seen or been involved in as well, is there's almost two stages of emergency lighting. I think we'll probably go into that a bit more detail later on, but it's just to be mindful that there's not always just one solution for one project. There might be multiple phases or multiple areas that need special consideration. So it's a really critical aspect and should be carefully considered irrespective of where you are.
Perfect, thank you. So that brings us quite nicely into our next question. What luminaire / product types should you utilise for effective emergency lighting? Yeah, if you want to start.
I can jump onto that one. So, Sean kind of touched on one of them straight away. That was the integral battery backed luminaire. So basically, where you've got the batteries inside the product itself. Historically, this tended to be one of the most common, if not the most preferred methods across all industries. Even non-hazardous areas, it quite often is battery-backed type solutions. Now, what those luminaires typically do is they will operate in both forms. You can get maintained and non-maintained emergencies, but typically what we see, for those of you that aren't familiar, maintained emergencies basically means that it's on, the emergency luminaire is on in normal conditions, and then obviously switches to battery mode in the event of a power failure. And then your non-maintained fitting means that it's not on under normal conditions, but will come on under battery mode or emergency mode in the event of a power failure. Okay, so you tend to have a bit of flexibility there in the design. Your maintained emergency luminaires will be often utilized on most projects, most facilities, most sites, wherever you are. They tend to provide your normal illumination in combination or in tandem, however you want to phrase it, with your standard products. So they provide your normal operating lighting levels across your facility. In the event of a power failure, they will then switch over to battery mode at a typically reduced output and give you your emergency lighting to safely escape the facility. Now, typically we will offer those battery solutions both ourselves, Chalmit and Killark. We'll offer those battery solutions in either a 90-minute or a 3-hour duration. Typically what we've seen, and I'm sure Karl or Sean might have comments on this as well, but typically what we see is a minimum requirement for a lot of sites of 30 minutes Some sites even go up to 60 minutes, but it's not that common, not that often for sites to consider 90 minutes and 3 hours. I mean, it depends on the area, I would say. Certainly, I know for the North Sea, it's typically standardized in 3 hours. But it can vary, again, depending on the location of the facility. So it really, I mean, as a standard solution, we can offer both 90 minutes or 3 hours. One other thing maybe to consider is the light source, the technology that you're utilizing in the product itself. Traditionally, most people would use fluorescent luminaires. Now, the reasoning for that is pretty sound. You have fluorescent lamps which provide a white light, good or high color rendering light source, so it gives you good color clarity across your route, your escape route, whatever that might be. And it also gives you an instant light output, i.e. when the power fails, it will switch over to battery mode almost instantaneously. So there's no delay there, and that's really critical. You need to be able to illuminate and highlight the escape routes as quickly as possible. We have seen some cases in the past of conventional HID solutions being used for emergency lighting, and I would strongly recommend against that. And the main reason for that is purely because of the time it takes for that light source to get up to full output. Fluorescent lamps are instantaneous. HID typically needs a few minutes, maybe even 10 minutes to warm up and get to full output. So you're not guaranteeing that you're getting your required illumination levels when you need it the most, okay? So LEDs have kind of made that a lot more universal than conventional products in the past. LEDs are universal, really. I mean, that's sort of the mantra that we're kind of talking about. Depending on how you control that light, depending on how you focus that light, can have a vast impact. So in an LED...
Oh gosh.
Sorry, let me...
Добре, Майна. Приятно вечер ти, Joy. Приятно...
Okay, so...
I've muted him.
Okay, thanks, Karl. So, sorry, just as I was saying there, so on an LED product themselves, I mean, you're not just solely confined to Luminaires type products anymore. You could use potentially any LED emergency product with a battery backup to provide illumination along an escape route. You just need to be careful about the location of that product to ensure that you get the desired illumination along that route itself. So, I mean, that's part of the beauty really of LEDs. There's a lot more universal. You can still get the high color clarity that I talked about on fluorescence. You can still get 870 to 80 CRI plus, and you get instantaneous light. Sorry, not lice. That's something different. Light. So when you switch over from your main
that's a competition.
Your battery backup, it will give you that immediate light to safely escape and safely egress the facility. Just one more thing to consider as well with regards to product types is your exit sign. It's something that's it's never the forefront, you know, for what you need on a facility. Typically, you consider the emergency lighting, but the escape signs are as important, if not more important, for some cases, because you need to be able to direct people safely out of a facility, out of a premises, and so they don't get lost in the building, the area, whatever that might be. So an exit sign is really critical. Now, it doesn't need to be a specific output. It just needs to provide safe illumination, what I referred to before as wayfinding illumination, to direct the individuals to the correct direction. Okay. One final thing, sorry, from my side, just to consider as well, is with regards to the number of emergencies on a facility. We've seen sort of varying information depending on where you're looking at or where you're using it, but in some cases we see 25%, you know, but as a general rule of thumb, along an escape route, you're probably going to need every second linear to be an emergency. But over the course or over the entire facility, I wouldn't be surprised at times if you're seeing in the region of 30 to 40% emergencies. Okay. Now, maybe I should clarify that. I'm referring mainly to linears rather than floodlights and linears and all products. But just be mindful, emergencies do take up a significant chunk, a significant portion of your overall project. Okay.
Perfect. Thank you. Sean, is there anything that you would like to add there?
Yeah, you know, maybe just some clarifying points just for the NEC side. Ken hit the nail on the head. I mean, most of the time these things are all universal. You know, it's trying to get people out as safely and effectively as possible. And whether you're using a linear, a well glass, which in the state sides we would call like a medium bay or low bay, maybe even high bay, or a floodlight. It's whatever light is suitable for getting the light to the ground so people can see how to get out, right? most of the standards for stateside only call out 90 minutes, but there are some site specifics, bigger buildings, where you're going to have that 3-hour limit. So just like Ken said, that's exactly why we offer that 3-hour option on there. If you look on our data sheets, you'll see that. So most of the time it's just a middle number that you change. So the output is going to be smaller, but it is going to last for the 3 hours. Some lights that are extremely common for the stateside are we call them the frog eyes. Affectionately, we call them frog eyes or Mickey Mouse ears, not associated with Disney. But those are essentially you used to see them all the time, like in your schools when you're a kid going to school. You'd have basically a big exit sign in the middle, and then they'll have an incandescent bulbs going, shining down the hallway. Those have been since replaced with LED, and we offer, granted, we don't offer one with an exit sign just yet. We are working on that, but we do have one with just the frog eyes, and then also for Class 1 Division 1 areas, we have the exit sign and the frog eyes. One thing that we do offer as well is as I mentioned with the UPS systems, Karl's absolutely dead right. They're also have inverters on them, but in the instances where they want to just shoot the DC line down to these fixtures, we actually have fixtures that operate both on AC and DC. So that way, it's essentially, it doesn't matter what the frequency is or no frequency at all in the DC case. It's just going to accept it and then produce light out. The last aspect is NFPA 101, the life safety code, which I keep referring to, is probably one of the most salient codes, I guess you could say, for our industry, at least from my perspective, and from NEC perspective. It allows for self-testing because you're supposed to go around every month and do a 30-second drawdown test on every single emergency luminaire. As you can imagine, that's a pain in the neck. That's almost a part-time job if you were to do everything in a facility. So they do offer this provision where you can do a self-testing. So once a month, we have this technology built into the Killark fixtures where it'll go through and self-test. Turn on LEDs. You know what you're doing? Perfect. We're good. Batteries, you have charge. Good to go, green light. And essentially, the person just has to walk around and look for flashing red lights because that means an error has happened. And then it also goes every 6 months to a year, and it does the full 90-minute drawdown test. And that ensures that the system is always going to be operational for people to be able to get out in the case of emergency, because these are not things you can just put up and forget. They do have to be maintained to a certain degree. And really, that's it. I mean, again, we try and offer the full range. We have our LAL series for linear. We have our VM series for like a well glass or medium bay. And then a floodlight, we have our new KFLX that we launched. And again, for me, I see that as primarily for like muster points, or you also have to light the path typically to that muster point. So that's where I can see floodlights being imperative for operation for that. So.
Mm-hmm. Maybe just to add on that, sorry, Liv. So Sean's 100% right regarding the self-test functionality. That's pretty crucial. Pretty well. It's a time saver. It's a maintenance saver. It's essentially a money saver, a project saver over the course of time. Historically, what we've seen is people going around manually with a stopwatch. So they will isolate the power to the luminaires. They will turn the stopwatch on and then come back in an hour and a half to check if it's still working. So it's a real, it's a real confidence booster to some extent to have that self-test functionality. The other thing to be mindful of is the lifetime of batteries. Now, batteries, as we're getting more and more into LED technology, LED products, both the LED light source, both the LED driver, tend to be pretty long-lasting components. They will easily, well, now that we're sort of seeing the lifetimes of 50, 80, 100,000 hours plus quite easily. What hasn't caught up yet is the batteries. Now, battery technology is still a little bit more dated. I've seen there's a question come in from Dimitri, so thanks Dimitri for contacting us today. You've asked about lithium iron phosphate there. So it's not something that we typically use, mainly from our experience in hazardous areas or harsh industrial areas. And that's mainly because of the extreme ambience that our products could be utilized in. Now, historically, for most of the environments, and we're not alone on this, nickel cadmium tended to be the #1 battery cell. If you look at most emergency lighting across commercial industries, nickel cadmium is something of old. You know, if for us, it's a tried and tested technology that's very robust in both ends of the ambience. Yes, at the lower temperatures, it still needs a bit of a boost, a bit of a hug, you might say, just to kind of ensure that the battery temperature is being regulated. What we've seen a movement more towards is nickel metal hydride as well, because it tends to use a much smaller type of cell rather than your traditional NiCads. I would, as a sort of general comparison, your NiCads tend to be like if you can imagine your D cells, your old school D cells. I can't even remember what we used to power D cells with, but used to have them in your household. Now your nickel metal hydride cells are more like your AA, maybe a little bit longer. So you can kind of vastly reduce the physical size of it, but also the weight of it. So there's lots of savings that then can be realized of your project. One other thing, maybe to just bringing it back to a project or a product, sorry, as well. So battery maintenance, because it's got the lifetimes that we're talking about. I mean, typically we're seeing 4 to 6 years, depending on the ambient that it's exposed to. Thanks, Chris. Depending on the ambient that it's exposed to, you can have some pretty reduced lifetimes. You know, extreme ambience will reduce the lifetime of that battery cell. So your battery replacement will often be more regular than anyone honestly wants. It's one of those things that you need to be very mindful of. So anything that can make maintenance of batteries easier is a massive benefit to you, your customers, your projects, your sites, whatever that is. One example that we've implemented in the Protector X is a hot swappable, externally accessible battery. Now that's really come about from a lot of voices from the market, from the customers, with regards to maintenance of batteries. So anything by a hot swappable solution, it means you don't even have to open up the luminaire. You don't have to isolate power. There's no permits required to do it. You could essentially just do that immediately when you need to. Okay.
Thank you. And if you want to find out a little bit more about our hot swappable battery, we do actually have a blog coming out about it this week. So look out on the Chalmit LinkedIn forum.
I just want to make one quick comment. You know, at Killark and Chalmit, we do things sometimes a little bit differently, and we do use lithium iron phosphate batteries in our products. You know, lithium iron phosphate is more stable than what we heard of with the Samsung lithium ion batteries, where they were, having bad issues. Lithium iron phosphate is extremely stable, and it, your battery packs are literally, like you said, about the size of 2 AA's. Maybe a little bit bigger girth, but yes, we do use lithium iron. We've had immense success with them, but he is right. You cannot take these lithiums below like -20, I think it is. Anything below -20, and you can do damage. So they absolutely have ambient restrictions on them. And if we're gonna, if you need a low ambient solution, we will have to switch you to a different battery technology.
Perfect. Thank you all. So moving back to the emergency, back to luminaires away from batteries for a second. Let's talk about locations again. Where should emergency luminaires be located? So Karl, if you want to kick us off on that one.
That's absolutely fine. Hi, I'm Karl. What I'm going to talk about here is really good practice for lighting design. There are an awful lot of standards out there. There are also a lot of site specifications which may differ from that, as we've discussed before. But what I'm going to take you through now is a bit of a, like I say, a good practice guide. So our guide for emergency lighting, the 5266, which is a harmonised European standard, states a minimum set of standards for emergency escape lighting for general onshore use. And it's a code of practice that outlines how to meet the European standards of 1838 and 50172. And what we do first of all is we have to do some sort of risk assessment. Now, it's either done by the fire chief on site, or if we haven't got that information, we may have to do a risk assessment ourselves. And what that risk assessment determines is where the escape route runs from the building, from every area of the building, where all the escape doors are, where all the anti-panic open areas are, which is areas over 60 square meters. We may have some high risk areas where we need some sort of essential equipment to be shut down. And then also where the final exit doors are, which is going to take you outside to a place of safety. So where you're going to place these fittings, there are a number of things in the guide that tells us that we have to have them in, and they call them points of emphasis. So I'm just going to list those points of emphasis now. So near every door that you're going to look to go through in order to exit the building, every set of stairs a change of direction, every intersection, and near the final exit doors, outside of the exit door, and an exterior escape route to a place of safety, like a muster area. And just to define that, they class near as being less than 2 meters. They've also got in there now, there's been a bit of an upgrade to the standard. They have started to include some defined areas. Okay, so some additional points of emphasis that we need to look at where we should absolutely put an emergency lighting fitting would be near firefighting equipment, near first aid points, near escape equipment for the disabled, call points, and any control points. Say you've got electric doors or some sort of mechanical control, and maybe a roller shutter door or something like that. There's got to be a fitting near there. Now there are some additional areas that they're saying that the standard says that we need to EM light, although they may not be part of the official escape route. So just to quickly go through there, we're looking at lift cars, escalators and moving walkways, toilets and tiled areas. Of course, they're going to be quite slippy, I guess. Any safety signs, so you could have, signs to this way to the muster area outside, that would have to be lit with emergency fitting, and escape routes in covered car parks. Okay, so we'll also look at high risk areas, which will be things like workshops with moving parts, where if there is a power failure, these machines have to run down, so you need instant light there to make sure that people don't get trapped in the dark with moving parts. Control rooms for process shutdowns, and any areas where we might have dangerous substances, say like we're in an iron works and we've got molten metal, or we're in some kind of chemical works and we've got, I don't know, concentrated ammonia. These are the kind of areas you absolutely have to light. Okay, so those are the areas listed for lighting and where we should absolutely place emergency lighting. Now we have a separate question here. I'm just going to, unless Liv, you want to ask the question, I'll move on to the levels.
It's okay if you want to carry on. By all means, go ahead.
I'm having a bit of a roll.
You want to roll? You want to roll? It's all good.
Okay. So the next question we've got here is what are the typical lighting levels required for emergency conditions, and where do those apply? Okay. So emergency light levels. So we split them into 3 different types. Okay. So we'll have escape routes. That seems quite simple. We're talking corridors and strips of walkway through open areas, which constitute an escape route. Now in these areas, we are looking for 1 lux minimum along the centre line of the escape route. Okay, so that's a minimum requirement for that escape route. Next, we look at open areas of bigger than 60 square metres, or have been risk assessed as requiring emergency lighting. So I'll go into what that means later on. But in these areas above 60 square metres, or what we class as anti-panic areas, we're looking to achieve half a lux minimum over the entire floor area, with the exception of a half-metre border around the outside. And then the third is a high-risk area, which contains dangerous processes, or maybe areas where equipment needs to be shut down. And in that case, we're looking for not less than 10% of the normal illuminance, and in cases where that normal illuminance may be less than 150 lux, we make sure that we have to achieve 15 lux, so not less than 15 lux in any case. Of course, offshore emergency lighting is a lot more stringent than onshore, and I believe Ken's going to elaborate more on this later on. But you may be asking now, how do we check or prove that we achieve the levels that are stated in the standards? Well, simple answer is we use computer software to calculate the levels based upon a design or a layout, and this leads me very nicely to Chalmit 6, which has recently been launched and is available from the Chalmit website. I believe we're going to put a little link in the chat. Hopefully Liv will be able to do that while I'm rabbiting on here. Yeah. So Chalmit, it's an incredibly good piece of software, if I do say so myself, and we're kind of we're catching up with the big guys of Relux and Dialux in terms of functionality. So that's good. Now we're going to have different presentations on Chalmit at a later date, so I won't go into it too much here. But what I am going to do is, at this point, is I'm going to share my screen, and we're going to work through a bit of an example, just so I can show you the standards which have been I've quoted before actually being put into practice. Okay, so switching over in a moment. Okay, so hopefully everyone can see this. This is a layout of a building which is popularly used in the standards to demonstrate where and when you need emergency lighting. Okay, so what's happened here is this: every room here has been populated with lighting fittings. They're all normal fittings, and they're all hitting the levels for offices or toilets or corridors or whatever you're looking at there. I think we've got a kitchen here as well. Okay, so what I'm going to do first of all is take you through this example. And the first thing I would do here is to turn all the fittings in open areas, i.e. rooms which require the open area lighting. I'm going to light them to half a lux minimum. Okay, so I'm going to go through it room by room. So here's a room, this little small office. It's less than 60 square meters, so technically it doesn't need an emergency fitting according to the standards. However, it does form part of the escape route for this little inner room here. So we absolutely do need to light this to half lux. So what I'm going to do is I'm going to change some of these to emergency lighting products when I find them. There we go. So we're going to replace that luminaire there, and we're going to let that luminaire there, and I'm going to switch to escape level so we can see. Okay, so now we can see in this room, small office, our minimum is over here. We've got 6.3. We're lighting the escape route to the door. Okay, great. So let's step through the next one. This room is small, doesn't technically need any lighting because it's smaller than 60 square meters. Kitchen technically doesn't need emergency lighting because it's less than 60 square meters. However, it is one of those special areas which is mentioned in the standards that does need special focus in emergency lighting. We need an increased level here and of 15 lux in order to get an average of 15 lux, and of course the emergency fitting has to be placed near to the door. Now we can see in this room our average in C, the kitchen, is now 24.7 lux. So we've lit that adequately. Now, here's another room. It's a little office, and it constitutes part of an escape route. So we'll absolutely need to put some emergency lighting in here, close to the escape door. And we can see we're getting 1.1 as our minimum. That's lit to emergency standards. Moving on to this big room. This is a big office, over 60 square meters. We're going to have to light this all the way to every corner with a 0.5 lux. So how I would do it is I would light the first one near the escape door, and then make sure that every area is covered by 1 lux minimum. Sorry, half a lux minimum. And our minimum level there, I think, is in this little corner, is 6.1. So we're well within the limits. Going to move on slowly now, or quickly, it's up to you. We're going to, again, this is an office less than 60 square meters, doesn't need emergency lighting, technically. And here is a toilet. doesn't technically need emergency lighting, but again, it's one of those special areas where it's going to be tiled and a slippy area, so it has to be assessed, risk assessed as needing emergency lighting. And the last area is the, sorry, that's it for the rooms for open area lighting. The next one we do is we look at the escape routes. So in escape routes, we have to look at the locations of emphasis. So we're looking at exit doors, stairs, changes of level, changes of direction, and intersections. So that's what we're going to do now. So where are our exit doors? We've got one here. Okay, that's good. That's got one near it. Brilliant. We've got now from this inner room, we've got one door. That's an exit door because it exits to this escape route. So we have to turn that to an emergency. And then this medium-sized office. Now this emergency lighting, but it will have a door which you're going to use to exit to get out of the building. And I'm going to choose this door here. I'm going to put that light fitting as emergency. Actually, no, I'm going to move that one. I'm going to go to that one. My mistake. I'm going to change that. So just bear with me a second. Pick the wrong one. Okay, so that's our light fitting, and it's 1-2 meters away from the door, so that works perfectly. Next exit door, we've got one here. That one's got to be changed to emergency because it's close to the exit door. And last exit door is over here, and we change that to emergency. Changes of direction. We've got a corridor here. We've got a change of direction. So this thing here has got to be an emergency. Okay, hopefully we're building up a nice picture of emergency fittings here. The next part is we've got to connect up our emergency luminaires so we can achieve our one lux down the centre line. So we can see our centre line here. We've got excessive lighting light here as we move along. Oh dear, we've fallen below 1 lux. So what we're going to have to do is make another fitting emergency so that all the lighting levels across there directly to the escape route is more than 1 lux. So the next thing is we've got to put some signage in. So here is a emergency fitting. So I'm just finding that. So this is an emergency fitting where we've had the exit legend placed in there. So final exit doors. We'll put a fitting here. There's a final exit door. I'm just going to change this to a better view so you can see what's going on with the icon. So you can see that that's an exit fitting. We've got another exit here. We can put one in like that. And one more exit door here. Now those are our final exit doors. What we have got is some rooms here where there are two. Yes.
This is absolutely fantastic, and
I
think
will be done in 30 seconds to 60
no,
seconds if you can interrupt.
No, all good, thank you. I think it's a really great overview of how simple the software is to use.
Yeah. Oh, thank you very much. It really is a very simple bit of software, and changing things around and designing in an emergency fashion makes things very easy, especially when you can just switch fittings to emergency types. But I've got a few more exits to put in, and then I'm done. So we've got a couple of rooms here where the escape path is not always obvious. So let's look at this medium office here. We've got 2 doors, and because we don't want any ambiguity between which is the path to the exit door, we put an exit fitting in. Similarly, if you were in this little room here, you've got 2 doors. If there's any ambiguity, you put an exit sign in. If there is only one door out of the environment, like say this kitchen, there's no need for an exit sign because it's obvious which way you go. And the last part of this design is we have to put emergency fittings outside of final exit doors. So here's a little next LED which we can put outside this door, a little next LED here, and then a little next LED here. And that, ladies and gentlemen, is a complete emergency design scheme completed. We've got all our fittings, we meet every part of the code. Okay, so I will now stop sharing, although I'm not quite sure how to do it. Here we go. Here we go.
No, that was great, and I'm sure if anyone needs support in the future, obviously Karl is here to help you, but Chalmit is there to make lighting design as simple as possible for you. So if you want to give it a go and make your own lighting design, the link is in the chat there for you. So moving back to some of our questions. Karl, earlier you mentioned about how the offshore standards are slightly more stringent than onshore. Yes. So are there any specific requirements that people should be aware of? I'll hand that one over to Ken, shall I?
Sure. Okay, thanks, Liv. Yeah, I mean, Karl was right what he said before, that offshore tends to be a lot more stringent, a lot more specific with what they need for emergency lighting. I mean, typically from the Chalmit brand of the business, this is kind of our main bread and butter, to be perfectly honest. It's really what we've always come from a marine background, and we've always focused on the offshore aspect of it. Now, what I would say is that offshore tends to take offshore oil and gas, sorry, I should be specific on that, tends to take a little bit more of a belt and braces approach. So they go to the far end of safety, just to be, well, on the safe side more than anything else. A lot of this has come about from the Piper Alpha disaster in the North Sea back in 1988, where we had 167 men passed away on that specific date. So ever since then, there's been a massive focus on emergency lighting and meeting, well, trying to avoid any potential cause, fire, ignition, whatever might be the case. What happened in that specific example was there were, well, one of the major instances, one of the major causes of all the lives that were lost was essentially lifeboats getting launched on top of each other, just purely because there was no overside lighting illuminating the sea surface so that people could see if the lifeboats had moved away and were clear before they launched another one. So, I mean, that kind of led to the introduction of overside lighting as an emergency requirement. So it's not just about escaping the facility or gathering to the muster point, but it's also about what happens after that muster point. So i.e. when you're launching the boats into the sea surface to ensure that people can safely escape. So that introduced overside flood lighting, typically again battery back type solutions to provide sufficient illumination over the sea surface itself. The other thing that's quite unique to offshore applications is lighting or emergency lighting for living quarters. Now, on most offshore platforms, they tend to be a combination of Zone 2 and Zone 1, but as a general rule of thumb, they just blanket it all Zone 1, just again in the event of any gas leak that might occur on site. Where this doesn't apply is in the living quarters, thankfully, for the people who are living on board the platforms. You know, they don't want to be constantly in fear of an ignition or something happening. However, so in those areas, they tend to be treated as safe area or industrial, whatever you like to call it. However, in the event of a power failure, the dedicated emergency luminaires do need to be rated Zone 1, typically. And the reasoning for that is in the event of a power failure, there could be a gas leak, and they want people to still be able to safely escape the living quarters, the cabins, whatever room they're in the living quarters, without any fear of ignition or causing a spark around the place itself. So your emergency lights tend to be Zone 1, whereas the rest of the normal lighting can be safe area industrial. That's why you quite often find combinations of industrial downlighters mixed with hazardous area recess fittings. Okay, so there's a certain balancing act there as well. One kind of thing to touch on is with regards to the different lighting levels for offshore as well. So Karl alluded to it a little bit in the last part there, but there tends to be 3 lighting levels. So normal is your normal operating lighting levels, but there are 2 emergency lighting levels that could apply. Now, again, it's dependent on site standards and site requirements, but typically you have what we like to refer to as essential lighting and escape lighting, both forms of emergency. Now, escape lighting is probably the more straightforward one, and one we've touched on and talked about quite a bit already. It's regarding battery-backed emergencies. Okay, so dedicated emergencies providing the illumination. What we intermediate lighting level, what I like to call essential, because the way I like to think of it as essential shutdown of equipment. That tends to be your intermediate level, where you have Typically, the same emergency luminaires are connected to a UPS or a central battery system or whatever that might be to give you 100% output for however long the battery cells are valid for, typically somewhere between an hour, half an hour to an hour. And that just allows for safe shutdown of any equipment or any things that are going on in the platform itself. After that essential shutdown has happened, the luminaires will then switch to emergency mode off the battery backup and allow people to safely escape along the the defined egress routes on the facility or the platform. Okay. One other thing to maybe bear in mind as well is to avoiding redundancy. So we've certainly seen a bit more traction towards the use of centralized battery systems on even offshore platforms, to be perfectly frank. Now, there are good and bad aspects of having integral batteries and a central battery system. We're not saying any one solution is right or wrong. You just need to be mindful of the pros and cons of each. If you have a centralized battery system, they typically are located in a safe area, so you can use industrial equipment to provide that. But you need to be mindful of having multiple circuits, so you don't just have one potential point of failure with a central battery system. So typically what you'll see is a minimum of 2, maybe even 3 or 4 centralized battery systems connected to different emergency products or different circuits, providing safe egress. Okay, that's about it.
Oh, Sean, I think you're trying to say something there, but you're on mute.
Fell for it, darn it. So the only thing I'll add is Callum brought up 2 things. First of all, yes, this is a unicorn scarf that keeps on showing up in my background. So sorry for that, guys. It's my daughter. But the second one is you also, so we talked about the self-testing, and that would be massively annoying if you had it in living quarters, right? You don't want in the middle of the night something coming up, or even in the middle of the afternoon if you're on an off shift or whatever. So we do have the opportunity to turn that off, turn off the self-test. So you have to physically go and test. So I just want to make that note.
Perfect, thank you. Well, we are at time now, so Ken, Sean, Karl, is there anything you would like to add before we finish up?
Nope, I'm good.
No, nothing more from me either. I mean, if there's any follow-up questions, folks, or anything you'd like to get clarified, whether from a design perspective or a best practice from our experience, by all means, please contact us, contact Liv, contact myself, whoever that may be, and we'll do our best to try and help and answer any follow-up questions.
Perfect. Well, thank you very much to our panelists, and thank you everyone for joining us today. We'll see you next time.
Thanks, everyone.
Thank you.